All right. We have some more questions, and I hope I can get it done on one recording. Okay. I hope if it's too long, you just have when you watch it, you just have to break it and pause and break it because we already have A, B. If we get it to D, I think it's a bit too much. Okay, so let's try to control it to be C. All right, for this one, you can see the algebra gets a little bit more complex, okay? So we'll continue to do the substitution method, but we need to be careful about the algebraic part, okay? So in this piece, I'm going to introduce U equals to 2 plus 3 times e to the power r. R here is a variable, okay? U would be equals to 3 times e to the power of r and er, the derivative of r, okay? We have a lucky late er times e to the power r times dr. The substitution, we just have to take some, tender loving care of this process, right? So this is a u, right? E to the power r is brought together with e dr, and these two makes 1/3 of du. So this, if I substitute by this du, I will have to multiply by 1/3. Or from here, you will see that if we divide both sides by 3 in this expression, so this is going to be du over 3 equals to e to the power r dr. Okay, so it's just a bunch of algebra. So by this time, we can find the antiderivative, right? 1/3 power rule, right? So it's going to be 1/3² plus 1 u raised to the power of 5½ plus a constant. Excuse me, simplify. So this is going to be 5½ so this is going to be 5/2. And 6, sorry, not 6, okay. 3 times 5, that's 15. So 15/2. All right, and u will be replaced by its equal. Its equal is this 2 plus 3 times e to the power r, okay? So just algebraically, we need to be careful, okay? We need to be careful. All right, so I think, method-wise, you probably got it already, okay? Just some algebraic details we need to be careful about. Okay, for this one, the substitution actually is pretty obvious. We're going to introduce u equals to arc sine. Okay, so du would be equals to 1/√1 minus x squared dx. All right, we have we have this situation given here. So this substitution is really pretty straightforward. It just helps us to improve algebraically. So this is e to the power u, and this piece and that piece together, that makes du. Okay, so this is just du. And e to the power u right there, e to the power u. You see, after the substitution, it's pretty simple, okay? E to the power u. And you want to make sure you show your work properly, okay? And in the end, substitute it back. Okay, our U is arc sine. So replace U and finish. All right. Next one, number 33. Number 33. I think this substitution is also an obvious one. So we're going to introduce U equals to tangent theta. Okay. And derivative U would be secant squared theta d theta. D theta. Okay. Equals to, all right, so this is a U secant squared theta times d theta, that's du, right? So we got du right there. So this, after substitution, our antiderivative is ln u absolute value of u, and plus a constant. And last but not least, I'm going a little bit faster, and I hope that if you need to pause or do it on your own, you don't need to watch this, it's fine. You can also come back to check answers if you wish to. And you can see there's some similarities. Right? There's some similarities. And as you're doing this more and more, you're going to improve your algebra. Okay, and this one is also going to be the same substitution. Okay, if you notice, okay, it's going to work. Okay, so by this time, as we practice more, we see more steps before we get there. Okay, so this is a u squared, right? And this is a du, right? And the antiderivative is a negative u, a negative 1 over u. Negative 1 over u. Or you can use power rule, however way you get it. Okay? Plus c, I'm sorry, plus c. Okay? And in the end, substitute. So tangent theta, replace u. Okay? Finish. And number 35 is also pretty straightforward, but I still recommend you guys to practice it because I'm going to just have the work shown here. Okay, I'm going to introduce u equals to arctangent. So we get to practice with all of these. Okay, so du would be equals to 1 over 1 plus x squared. Okay, so we get to use all of those derivatives, antiderivatives in these exercise. In addition to that, we got to practice our algebra. So this is u squared, and that is du. So we have it. We have it here, so it's just du. Okay, so that's just u squared, in other words, right? And the antiderivative is going to be 1/3. Oops, sorry. 1/3 as u to the power 3 plus a constant. All right. Almost there, replacing u by its equal. Okay, replace u by its equal right there. Okay. You can see this, some of the substitutions, you already seen through it, but still practice with the algebra, okay, because it should help us with our calculus algebra, okay? And hopefully we will be well prepared for our next class. And this one, the substitution is also going to be the same. Okay, I'm doing even number and odd number questions. Okay, I hope you have noticed. Okay, arctangent is, this is a u, right? So this is x squared, and this is going to be under. I can put it under this piece, right? Same thing. And that's du. So this piece is du. And it's ln, oops, ln absolute value of u plus a constant, right? And last but not least, Ru is arctangent. Boom, finished, right? Okay, and this number 37, the substitution, I think, is also obvious. Okay, the substitution is obvious. So it's just going to be u equals to 5 raised to power t. Okay, so du equals to the derivative 5 to the power t is 5 raised to the power t ln 5 dt. Okay, so we have an extra constant there. We have an extra constant here. And go back to the substitution, right? Go back to the substitution. Then we know that this piece is going to go with dt, right? So this is a u, and this piece, we're going to move it closer to dt. So we can see better, 5t ln 5 dt. So bring ln 5 to the front, right? And this looks confusing, so we put a parentheses. So 5t dt, 5t dt, but how do we isolate 5t dt, divide both sides by ln 5. Okay, so 5t dt, so you just do a little bit algebra. So you're gonna get du over ln 5. Okay, so 5t dt will be replaced by du over ln 5. Oops, we're going to replace that. Okay. ln 5 is a constant. ln 5 is a constant. So you can, don't try to make this a decimal number. You don't need to grab that calculator, okay? Just leave it as 1 over ln 5. And this is du, right? And then you're going to find your antiderivative. So you got a 1 over ln 5. It is just a constant, okay? The antiderivative sine u is negative cosine u plus a constant. Okay, wrap it up. To wrap up, sorry. To wrap up this question. Okay, so there's a negative sign. I'm going to put in the front. Cosine u, replace u by 5 to the power t. Okay, and it put a parentheses there. Put a parentheses there. I don't think the parentheses is necessary here, but it was put in the original expression. So we just put it there. No harm. No harm done. Okay, 38. How are we going to substitute in this case? Think about it. So let's think about it. how are we going to substitute in this case? Okay. All right. I would, okay, take the entirety of the denominator and substitute. Okay. Then du will be equal to, then we're going to apply a chain rule to differentiate sine squared. So that's going to be 2 times sine theta cosine theta. Okay, and d theta. Those academic questions, they make it possible. Okay, they want us to be able to solve it, right? So this is a u sine theta d theta, sine theta cosine theta d theta. We got it 2 times. So we just divide both sides by 2, right? So you can see on the other side of substitution, you can work this out, right? Sine theta times cosine theta multiply d theta, that's going to be du over 2, right? So that part can be replaced by du and multiplied by half. That's it. Okay, almost there. We got 1/2 ln absolute value of u plus a constant. Okay, sorry, plus a constant. And last, substitute. Substitute, replace u. And wait a second. You see, sine squared theta is always at least 0. Plus 1 is always positive, right? So if this is the case, we actually can drop the absolute value. And of course, for the latter one, we have to put a parentheses. Okay, so sometime we could drop the absolute value, even though having the absolute value there is safe, right? But if we can drop the absolute value, then drop it, okay? All right. Okay, 35, I'm sorry, 39. 39. We're gonna assume u equals to 1 plus 5t. So du is equal to 5 times dt. Substituting, we got, right? This is a u. dt is 1/5 of du. So replace dt by du. We generate a constant 1/5. And then we're done. We're almost done. Equals to 1/5 sine u, right? The derivative sine u is cosine u plus a constant, right? And last but not least, this is a 1 plus 5t replacing u, and make sure you put a parentheses here. Done. 40. You see, algebraically, it gets a little bit more complex. It gets a little bit more complex. It demands more care to the details. Okay, more care to the details. So we're gonna bring it here. So how? But in these questions, you can see it's pretty obvious as to how we're gonna introduce the u, right? At least has become more and more obvious. Okay, so pi, u equals to pi over x. What is du? Pi is a constant. Pi is a constant. So we treat it as a constant. So this is going to give us negative pi over x squared. Okay, dx. We got an x squared in the denominator, right? And so this time, this is just a u x squared. I can bring it under dx, right? So this piece just a cosine u. Okay, dx over x squared, dx over x squared. We just have to divide both sides by a negative pi, right? So dx over x squared, right, is equals to dx over x squared is equals to negative 1 over pi du. Okay. So now we're going to substitute dx over x squared. That's going to be by negative pi over u. So it's going to be replaced by du. And negative 1 over pi, I'm going to bring it to the front. Right? So take our time. Don't try to write it down and break it into too many parts. Okay, just this one entirely x, this one entirely u. Okay. All right. So next step, antiderivative. Antiderivative sine u plus a constant. Oh, plus a constant. Sorry. Okay. And substitute it back. And u equals to pi over x. We don't need the parentheses, okay? We really don't need this parentheses. But if you like to put it there, it doesn't hurt, okay? All right. The next one is the substitution is also apparent. Okay, so we're going to use u equals to cotangent t. So du equals to cosecant squared. Oh, no, x. I'm sorry, not c. X dx. Do we have a negative sign here? Let me double check, okay? All right, I did check that there's a negative sign. Okay, that's what I suspected. All right, so then algebraically, we have to be very careful. Okay, we just be very careful because there's a negative sign there, okay? So cosecant squared is negative du. So this is going to be negative du here. This is u. So this is going to be replaced by negative du. Okay, and if you like to bring the negative sign to the front, and you can do this. All right. And the next step will be easy for everybody, I believe. So this is going to be 1 plus half u raised to the power of 3 half plus constant. Okay, so this is going to be 3 under 2 and substitute u. U is a cotangent x. U is cotangent x right there. Okay. 42. 42. Okay. I'm gonna bring this one down here. Okay. All right. The substitution is going to be obvious. It's going to be the entirety of the denominator. Okay. So du equals to 2 to the power t ln 2 dt. Okay, I have an extra constant right there. Okay, so let's finish. Let's finish, right? So this is a u 2 times 2 to the power t dt, 2 to the power t dt. So solving for that, right, from this relationship. So 2 to the power t dt, we would divide both sides by ln 2, and that's going to be du over ln 2. Don't need to use a calculator. Don't need to use a calculator. Okay, just replace 2 to the power t, right, with 2 to the power t dt by du over ln 2. So now entirely substituting. ln 2 can be brought to the front. Okay, ln 2, bring it to the front. And right here is just du. Oh, sorry, ln 2 should be here, my bad. Okay, in the denominator. And the next step, we got ln u absolute value ln u plus constant. And u is 2 to the power t plus 3. And here we got another interesting fact to use, because 2 to the power t is always positive, right? It's always larger than 0. Okay, 2 to the power t is always positive for any real number t. So 2 to the power t plus 3 is also always positive. So we can drop the absolute value. We can drop the absolute value. Okay, so that's the flexibility we get when we have a situation like this. Okay, so let's move forward. It's pretty late, but I want to finish it today. Okay, 44. All right, so how are we going to do this? It actually uses some other facts. Okay, so I'm going to first introduce u, right? I think our first instinct is going to take a 1 plus tangent of t as u, right? So that will reduce the question. And du equals to secant squared. I'm sorry, du equals to secant squared t dt, right? But secant squared. But wait a second. Cosine is 1 over secant. So cosine and secant are reciprocal to each other. Okay. So on this step, this piece, which is under, is actually secant squared t. You can put it on the top. Okay, so this will be u secant squared t dt, that's du. Nice. Isn't that nice? Okay. With some familiarity with trigonometry, trig functions, with definition, right? We need the cosine and secant are reciprocal to each other. So we got a secant squared right there. So this is basically 1 over cosine squared is secant squared, right? So we got that. Okay, so let me just write down that fact for you. Okay, by definition, okay, secant, okay, secant t equals to 1 over cosine t. All right? And now we're going to use the power rule. We're going to use power rule. Okay, so this is du, and this root u under the u, under one part, we're going to use negative 1/2. Okay, so we're going to use power rule to finish the integration. All right, so that's going to be 1 over, so this is actually going to be 2. Oh, sorry, 2 times, can I go a little bit faster without making a mistake? Without making a mistake, plus a constant. I think we're good. I think I'm good. Okay. And last but not least, replace u. Okay, so replace u. There we go. All right. Next, I actually don't know how much time has passed. Let me see, can I finish? Actually, all right. All right. Maybe we do need to make another recording. But the last few questions are pretty difficult. Okay, the last few questions are pretty difficult, but let me see if we just get to maybe 48. Okay, all right. 45. 45 it uses some other facts in trigonometry. Okay, so we're gonna yeah, we need to do this. Otherwise, so this is the opportunity for you to improve your algebra, enhance your trigonometry. So it's all worth it. It's all worth it. Okay, so derivative. So it's 2 times cosine x. Okay, and negative sine x, because the derivative of cosine is negative sine. So this will give us negative 2. Oops, sorry. Okay, so negative 2 times sine x cosine x. Okay, 2 times sine x cosine x, that's sine 2x. So this is going to be negative sine 2x. Okay, double angle formula. But don't forget the dx. Okay, let's not forget the dx. Okay, so let's not forget the dx. So sine 2x, right? So we got that substitution part. So this is our u sine 2x dx, sine 2x dx. That's a negative du. Okay, so I'm going to write this down here. Du equals to negative sine 2x dx. So now it's obvious that sine 2x dx is negative du, right? So over here, so it's a negative du, negative sign, I put in the front. Okay. All right. And the answer is going to be negative ln u, absolute value. Okay. It's safer to put absolute value. Okay. And once again, in this case, u in our assumption is always going to be positive. So I'm going to drop the absolute value sign. Okay. All right. 46. 46. 46, the assumption actually is similar. Okay, we should introduce the same U. But in 46, let me double check if I hope I didn't copy the question. I copied the question correctly. Sine x 1 plus cosine square. All right, I did copy the question correctly. Okay, so we're going to use the same substitution. We're going to use the same substitution. However, well, if it doesn't work, we just try something else, okay? So du, so that way du equals to this long thing, but we don't have sine 2x, right? So what are we going to do? What are we going to do? Is this going to work, right? So no fear, we can just experiment. If this turn out to be the case, we experiment, right? So I'm going to take du, I'm going to take the whole of it. Okay, du. I'm not getting there. I'm not getting there. Okay, I'm going to put the negative sign in the front. Let's see what we're getting, because we have sine x dx. Sine x dx. Right, sine x dx. And we got 1 plus sine squared, cosine squared. How can we, finish that? How can we get that done? This looks like it's not going to work. Okay, I'm going to show you whether it's going to work. Okay, so let's give it a try. Let's give it a try. If we, well, we have always make it work, right? All right, let's see a case maybe it doesn't work, right? So this is u and sine x dx. We still have a cosine x, right? We still have a cosine x because sine x dx, we have to divide both sides by 2, negative 2 cosine x. So this is not going to work. So what are we going to do if it doesn't work? No fear. No fear. It's not working. Okay? So then we have to seek out some other methods. All right. This is not working, right? So what are we going to do? Well, I'm thinking of something we can do, right? Because we know, so now we really need to work on a scratch paper. Scratch. So you're going to see me scratch. Scratch paper, not pepper, right? Scratch paper. So this is not working, right? This is not working. The assumption is not working. Then how about we introduce u equals to cosine x? Okay? I'm thinking, u equals to cosine x. Why am I thinking of that, right? It's just a flash of thought going through my mind. And this, the bottom here, so I'm just gonna scratch it out for you. So this is gonna be u squared. This is gonna be u squared, right? And the du equals to negative sine x dx. And we have sine x dx. There we go. This is going to work, right? So sine x dx this is going to be negative du, put a negative sign in front. Do you see that? Okay. So sometimes the same method, the same substitution doesn't work. We have to try something else. So I'm going to try u equals to cosine x. Cos and du equals to negative sine x dx. All right. And then we got this is a u squared, right? Sine x dx, right? That's negative du. So that's negative du, and there's a negative sign in front of it. Voila. So we got something that's arctan or arctangent u. Okay? Plus a constant. All right? So it wasn't the end of the world because these are academic questions. They didn't mean to make our life impossible. Okay? They did not mean to make our life impossible. There we go. So you can see by trial and error. Okay, we'll figure out. And you can too. Okay. 47. There we go. 47. Oh gosh, this is a bit too late today. But anyway, let's do it. Okay. So what I'm going to do is that we don't know the antiderivative of cotangent. We know the derivative of a cotangent, which is a negative cosecant squared. But we don't know the antiderivative of cotangent, right? So what we're going to do, we're going to rewrite it as cosine x over sine x. And then it's just substitution. Okay, so how are we going to substitute? We're going to use u equals to sine x. So du equals to cosine x dx. Right? So this is pretty straightforward from this point. Okay, so this is a u cosine x dx, that's du, right? So you can see that's du. And the answer is going to be ln u with absolute value to be safe. All right. Oops, not equals to c. Why do I do that all the time? Okay, last step. Substitute u by sine x. Can we drop the absolute value here? The answer is no, because sine x can be positive or negative. Okay, we cannot drop it. All right, 48. Okay, 48. I feel we can do it. Okay, well, it's just the only thing is that it's going to be a bit too long. Okay, but you guys can work it. All right. The substitution formula. I think we probably don't need the formula by this time. Okay, and to me it's pretty obvious. I don't know about you. I think it's pretty obvious we introduced this, right? So du equals to 1 over t dt. Okay, we do have a divided by t. So you can see here, dt over t, we will already have a du, right? So this piece should be should not be difficult. This is the u dt over t, and that's the du, right? So this is du. So no hustle at all. So as a result, I expect everybody to know how to do these, right? The antiderivative of cosine u is sine plus a constant. All right, last but not least, substitute u by its equal, which is ln t. ln t. Done, finished. 49. So I'm not going to bring that formula with us anymore. And this time, I think the substitution should be sine, arc sine x, Okay, so du would be equals to 1 over root of 1 minus x squared dx. Okay, and as for substitution goes, we got this piece is u, and this piece under dx, that's just du, right? So that's just du. Voila, this is actually very straightforward. So you can see, I expect you guys to be able to do these as at ease. All right, finished. Equals to ln u. You may think of if I'm going to draw it, can I, drop the absolute value sign? The answer is no. Okay, because the range of arc sine is between negative pi over 2 to pi over 2 inclusive. Okay. All right, we got to 50. 50 gets a little bit more difficult. Okay, 50 is a little bit difficult because if you think of using u equals to 1 plus x to the power 4, you can try it. Okay, but I'm going to tell you it's not going to work. So you may like to pause here. To try that and see why it doesn't work. Okay, I'm not going to show that part, but I just tell you it doesn't work. So I'm going to introduce u x squared. Okay, so du equals to 2x dx. And I got x dx, so x dx, so du divided by 2 is x dx. Okay. Then you say, why did you think of that? Well, because I did it before preparing for this lesson. I checked out some questions. So I did do my homework on my scratch paper before I did the recording. Because I really want to save time. I don't want to expose all my mistakes and my struggles. Like, yes, believe me, I do have a struggle, okay? So x to the power 4 will be written as x squared to the power of 2, okay? So now with that, this is going to be u squared and x dx, right? And that's du multiplied by half. And we certainly know the antiderivative of 1 plus u squared under 1, right? So we got arctan u plus a constant. And last but not least, okay, u will be replaced by x squared. No parentheses needed. All right. Next one. 51. What are we going to do with 51? Okay. You may think of, but this time I'm going to show you. Okay. If you think you're going to have u equal to 1 plus x squared, and right? It's actually not going to work. Okay, I'm going to show you why it doesn't work. Okay, du is 2x dx. Okay, so what's going to happen is that you will have a hard time matching. You're going to have a hard time matching the top because we didn't just have x times dx, we have 1 plus x. Okay, so you can have this u, but how do you work with 1 plus x, right? So that's a hard one. So let me just show you the answer. Just the answer is that this is not going to work, okay? Now we tried it, so what I'm going to do is I'm going to split it. I'm going to split into another piece, okay, sum. So 1 plus x split into, we keep the same denominator, okay? We do the substitution, the previous substitution on the second part, okay? You can see that it gets a little bit more interesting, yes? It gets a little bit more interesting. For the second part, we're going to introduce the u equals to 1 plus x squared. So the u equals to 2x dx. Okay, so that's my u x dx, right? X times dx, that's half of du. There we go. Okay, so this question is more interesting. Do you agree? I'm sure you do. I'm sure you do agree. And this is going to be ln absolute value of u finally plus the big constant. Okay. Do you think we can drop the absolute value in this case? The answer is yes. 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 Okay. So 1 plus x squared will be substituting u, and this is always a positive, right? So we can drop the absolute value. Here we go. I think we're going to finish this, okay? This one, 52, 52. 52 is obvious, okay? It's obvious that we're going to have to introduce the u equals to 1 plus x. However, we do run into some complexities, but if you look at this, you will get it. Okay, du equals to dx. Then you say, what are we going to do with the x squared? Okay, you may like to try this on your own before you see my answer, but I'm going to show you my answer. Okay, so du is the same as dx, so I'm going to replace dx by du, but what are we going to do with x squared? Well, no fear, guys, no fear. From here, we know that x equals to what? X equals to u minus 1. Yes? If we recognize that, we just simply replace x by u minus 1. Ta-da! Okay? Okay. So now what do we do? Well, we have to, FOIL and distribute. Okay, so that's the algebra part. Okay, so FOIL this part, we are getting u squared minus 2u plus 1. Do we have to do this way? Yes. Yes. and multiply root u with each piece, okay? And of course, this is u raised to the power of 5/2. And this is u raised to the power of 3/2. And this is u raised to the power of 1/2. Yes, it does get to this place. And then you're going to find antiderivative. Okay, then we're going to find antiderivative one by one. All right, so this is a good opportunity to practice our algebra. Okay, so this is u raised to the power of 7/2 minus 2 multiply, apply the power rule. So this is going to be 1 plus 3/2 and u raised to the power of 5/2 plus 1/1 plus 1/2. You know the drill. You have practiced plenty, right? Raised to the power of 3/2 plus a big constant. Okay, reduce. Please be patient with ourselves. Okay, so this is going to be 7/2. Sorry. This is going to be 5. Oops. This is going to be 5/2, right? So that's going to make 4/5. And this is going to be 3/2. Last but not least, substitute 1 plus x in the place of u. Okay, parentheses. So we're going to substitute every u by 1 plus x. Yes, this answer looks a little more complex. We did it. We did it. Well, 6 more to go. Okay, they are getting increasingly more difficult. Actually, it's not too bad. Actually, it's not too bad. I'm not trying to scare you. Okay, I'm not trying to scare you. Over this one, we're going to have u equals to 2x plus 5. Okay, there certainly is more difficult than a lot of other questions, but it's still manageable. You can do it. You can do it. Okay, du equals 2 times dx, right? So we are doing this. We are doing it. We're doing it. Okay, so this is a u, and du equals to 2 times dx. So if we change this to du, we're going to get a half, right? But what are we going to do with this x? No fear, no fear, because from here we can solve for x, right? So x will be equals to u minus 5 divided by 2. U minus 5 divided by 2. All right? So we're going to take this piece and substitute x. So now the substitution is complete. The substitution is complete. Okay, I hope you guys see that. All right. Organize 2, take it out, right? So this is a 4. U minus 5, right? U minus 5. Okay, so we're going to have to distribute. We're going to have to distribute So u to the power 8 times u, that's going to be u to the power 9. Okay. Minus 5 times u to the power 8. Did I get that right? Okay, u to the power 8 times u to the power 9, 5 times, okay, so this, we need a parentheses here. And just, you can write separately if you wish. Okay, so this part, and subtracting, we're gonna check, okay, we're gonna check. There we go. 1/4 u to the power 9 minus, and just 5. Okay, and bring that 5 outside. Okay, you better follow me, or you pause, right? You pause. So 1/4 u to the power 9 du, 5/4 u to the power 8 du. Okay. Antiderivative. So the first one, 1/4 1/10 u to the power of 10 minus 5/4, sorry, and 1/9 u raised to the power 9 plus a constant c. Wait. Plus a constant c. Oh gosh. The software could run weird. Okay, so I just saved it quickly. All right. Simplify, you can see algebra-wise, it gets a little bit more work. Okay, so this piece is going to be 40 under 1. And this is 36 under 5, right? 36 under 5. And the last but not least, we'll bring you back to our last expression. Okay, and I will substitute every u properly. Okay, all right, I think we can finish. Okay. Now we have a little more complexity. Okay. So obviously the u is going to be x squared plus 1. Okay, du equals to 2x dx. So when we are trying to substitute, right? So we get a root u there. X raised to the power 3, I'm going to bring it to the side closer to dx. I'm going to split x to the power 3 into x squared and times x. Do you see the reason why, right? Because x times dx is half of du. So this piece will be replaced by du over 2. How about x squared? X squared is u minus 1. X squared is u minus 1 right here from this relationship. Okay, from this relationship, x squared equals to u minus 1. So you see there's a lot of flexibility. There's a lot of details algebraically that we need to attend. Okay, so if you can practice this many exercises, I guarantee that you are going to be so good at doing this. Okay, so du here. So now we're going to distribute, right? Distribute, what do we get? We get u raised to the power of 3 halves minus u raised to the power of half. Okay, there. And another way to show you, okay, the antiderivative u raised to the power 3 half. So I'm going to put a bracket because we're going to have 2 of those, right? So we're going to have 1 over 1 plus, I've done this many times already, 3 half, u raised to the power of 5 half, subtracting 1 plus half, u raised to the power of 3 half, and plus the constant outside. Okay, plus the constant outside. So this is a 5 under 2. And this is 3 under 2. Okay, if we multiply the half inside, it will be gone, right? So one more step, if I multiply the half inside, boom, boom. So this will be, we can drop the bracket and we just have 1/5. 1/5. And here is just 1/3. Done. Almost. Substitution of u, which is x squared plus 1. X squared plus 1. X squared plus 1. Okay. All right, we have 4 more to go. 4 more to go. Yay. All right. My u is going to be x squared. U is going to be x squared minus 1. Okay, du equals 2x dx. And in my substitution, so this is going to be u to the power 3 x times dx, right? Did you see that? That's the half of du. So half of du, so I'm getting a 1/2. Okay. 1/2. Okay. Antiderivative 1 over 4. U to the power of 4 plus the constant. And let me just stand back and take a look. Okay. X dx. Excuse me. So this is going to be almost done. Let's get this done. Okay. I am a little bit tired. Last but not least, substitute x squared minus 1. I hope I did not make too many mistakes. But if I did, please let me know if you spot them. Okay. 56. 56. And this substitution is also apparent. So u equals to tangent theta. Okay. And du equals to secant square theta d theta. All right. So our substitution, this is going to be u to the power 3. And this piece is du. Okay. equals to 1/4 u raised to the power of 4 plus a constant. So the final answer is going to be tangent theta, substitute u. Okay, so theta should be outside. There we go. Two more. Okay, I think that I'm sure you can do it by this time. A lot of these. Okay, I just want to give you an answer. Okay, u equals to cosine x, so du equals to negative sine x dx. Okay, the substitution will become, this is a u sine x dx, that's negative du, right? So this du, negative sign placed outside, and that equals to negative e raised to the power u plus the constant. Finally, we are almost done. I'm going to crash. U equals to cosine x, final answer. 58. This is really the last one. Okay, these kind of questions actually, you see a glimpse of Calc 2. Okay, Calc 2, we have similar questions. Okay, and this substitution actually is going to be the same as the one we just did. Okay, so we're going to use the same substitution. So this is going to be u to the power 4. Okay, sine x is going to join the dx. And it's a negative du again. So this is a negative du. Negative du. Okay. All right. So this is going to be a negative. Okay. Du. Antiderivative. So negative 1/5 u raised to the power of 5 plus a constant. Yep, you already started seeing questions from Calc 2. Okay, so this is going to be replacing u by cosine, so cosine to the power of 5 x. Final answer. That's it. That's done. Thank you for watching.